So my name is Max. I spoke to you earlier this morning where I presented our innovation lab of the work that we did in NATURANCE. And there, I promise you, we will get back to this cost-benefit analysis and kind of the methods that we identified and that we also further developed to do this type of analysis. So if you remember, there were lots of, there was this analysis where there were costs and there was a range of different benefits. So how do we go about filling in this puzzle of a cost-benefit analysis for nature-based solutions? So that's what we're going to, at least in the beginning of the first half of this session, we're going to try and solve. And of course, then also identify, well, who are the beneficiaries and who can potentially contribute to financing nature-based solutions. And as we will discuss also, there might be, under specific conditions, there might be a role for insurers to play there. So that's enough from me. Let's go, get to the specialists who did most of the hard labor for this work. So first I want to introduce two colleagues of mine who did the work for NATURANCE from our side. So first we have Veerle, who developed a hydrological model for a specific catchment that accounts for specific nature-based solutions. And of course, this allows for assessing what is the risk reduction of these nature-based solutions. Then Guillermo will focus on the cost-benefit analysis, combine the numbers from Veerle's study with the numbers of the co-benefits to conduct the cost-benefit analysis. After that, we will have two presentations by industry experts, so specifically from the insurance industry. First, we'll have Gunn, who is the head of water and flood and water risk at Willis. And then a presentation by Vylon Ooms, who is a senior policy advisor at the Dutch Association of Insurers. And the idea is there that they are going to reflect a bit on the research that is out there and how this can be used to upscale finance for nature-based solutions with a particular focus of the role of insurers in that. So that was my introduction. I would like to give the floor to Veerle first. And after every presentation, we will have some time for questions.
Yes, welcome everyone. I hope you're still full of energy for the very last session of today. I'm going to tell you about a little bit of a different field from what we've heard so far. So I myself am a hydrologist, so I'm not in finance, I'm not in insurance, but I do work on nature-based solutions. And my work is to develop models so that we can quantify the flood risk reduction, specifically of nature-based solutions. So what do we know? Well, we do know that nature-based solutions seem to be very promising. I think we can all agree with that, since we're all here today. But what we've also seen is that the investors itself are still a little bit hesitant. There's this financial gap. So how can we try to fill this gap? Well, one of the things is that it's still a bit uncertain how well these nature-based solutions perform. How much flood risk reduction do they give? And a very practical example of, well, what is this information useful for? For example, if you have an insurance company and you have houses and they pay a risk-based premium, well, if you invest in these nature-based solutions, the risk goes down. So maybe households have to pay less premium, or you have to pay less insured damages back to your houses if they are flooded. So the goal of today is to model the effect of several nature-based solutions in one comprehensive framework. So let's move towards the study area. Max already slightly spoiled this morning, but this is the Veerle catchment, which is a transboundary catchment. It's in the south of the Netherlands, which makes it very like an unlikely landscape for the Netherlands. It's a very hilly area. Well, most of the Netherlands is flat. We would almost call it mountains, but I wouldn't dare saying that here. And it was flooded in 2021. This is what it looked like. Which has been like one of the biggest floods in the recent history of the Netherlands. And it resulted into around 250 million insured damage, which is huge. And this in the Netherlands, especially in the region, sparked a new discussion of, what should we do to better prevent and protect ourselves from these floods? So we need new adaptation measures. So what we also did in this study, Max already said it this morning, together with our stakeholders, which is partly the water authority in the area, we designed these measures so that what we're doing is also actually useful for the people in the field. So let's look into these measures a little bit. So we decided to focus on 3 measures. So the first one is reforestation, which is also actually in the Dutch policy documents. There's this policy aim that we increase the amount of forest in the Netherlands by 10%. So what we did for our scenario is that we increased the amount of forest by 10%. Another nature-based solution could be to convert agricultural cropland into more natural grassland, which you can see in the middle. And to be able to compare these scenarios, we use also 10 square kilometers. And the third one are storage ponds, or if there are any Dutch people here, we usually call them waterbuffers. And this is what's so far the status quo, I would call, in the area. There's many of these ponds, I think around a little over 100 in the catchment. So they're small-scale ponds, and then if there's heavy rainfall, the water is temporarily stored in there. So what did we do? Well, in our model, we made them a little bit bigger so that they can store more water, but also to create new ones more upstream. But now to the tricky part, because I just introduced these 3 measures, but they all function in a different way. So I want to take you along to this flood chain. So we start with very heavy rainfall, and then we end with a flood. So we start with rainfall, and then the soil slowly gets saturated. And this is where, for example, reforestation, but also conversion of cropland to natural grassland comes in. These measures allow for more infiltration in the soil. So there's less water that becomes runoff and starts streaming towards the river. And the porosity of the soil increases. That means that we can store more water in the soil, which are both very beneficial for preventing floods. Then there's the storage ponds, which prevents the excess of water to be able to flow into the river. Well, once the river starts flooding, you could also think of measures that enlargen the riverbed, so to provide a little bit more space for the river. We didn't look at that in this study, but it is one of the promising nature-based solutions. And then when the flood really becomes a problem is when we as humans interact with it. So once the flood water enters our homes, it becomes mostly a problem. And there's also specific measures on this, which are building level measures. I won't be going into that today, but if you find it interesting, I do work on that within my PhD, so you can always talk to me about that later. And then there's this big chain, right, of how this works. And then in the modeling world, we use different models for each of these processes. So the first part we model into a hydrological model, which mainly translates how a drop of rain ends up in the river. We have a hydrodynamic model, which simulates the water in the river, how it spreads over the floodplain. And we have a damage model, which translates these water depths into damages. So this is what comes out of the model. This is one of the cities that was very heavily flooded during 2021. It's called Valkenburg for the people who know, but you can forget that. And then you can actually see which houses had very high model damages. So that's what comes out of this model. And then I think we all know that models are models, right? So we need to have a little bit of trust in them. I think it was also raised before, to be able to, for nature-based solutions to attract investment, we need to have trust that it works. So we also need trust in our models that model these things. So what you can see here in the big picture is a comparison of what we modeled as the flood extent for the big 2021 flood versus the observations. So during the flood, aerial pictures were taken, so we really know which parts were flooded and which weren't flooded. So in green, you can see what we call hits. So those are the areas that are simulated as flooded, but were also flooded in reality. Then there's red parts, which are misses. So those are the parts we don't model as flooded, but were flooded in reality. And then there's the third category, which is false alarms, which are areas we say, well, this was flooded, but were not flooded in reality. And you can combine these three metrics into one big metric. It's a bit technical, but that's the critical success index. And in this case, it's 0.74. And I know that doesn't mean a lot to most of you, but 1 means it's a perfect match. And anything above 0.6, from a modeling perspective, is actually quite a good job. So now we know that we can have trust in the results of our model, which is always nice when doing such an exercise. So then we did a small cost-benefit analysis where we looked into what are the physical effects on reducing floods. So we looked into the flood extent, and then the do-nothing scenario is, well, how the landscape currently looks, and then you have a flood extent of around 9.8 square kilometers. And then you see for the first two nature-based solutions, so for reforestation and for conversion of agricultural land and cropland, that is reduced by more or less 1 square kilometer, which is quite a bit. And then you have the storage ponds, which don't do a lot, from 9.8 to 9.7. And then we can transfer this reduction also into a monetary value. So we hydrologists like to talk about expected annual damage. So that's on average the damage you can expect from flooding to occur in a year. Because we sometimes have big floods, smaller floods, and you can average that out. So in the normal situation, it's almost 8.5 million euros a year. But you can see if we implement these nature-based solutions, it quite drastically drops to around 5.3 expected annual damages per year, which is, I would say, quite a lot. It's a difference of around 3 million euros a year, which are like the direct flood risk reduction benefits we gain through these measures. And then you have the expansion of the storage ponds, and you can see that the difference there almost, well, is nothing, I would carefully say. And that's the main reason, is that the storage ponds, they fill up, and once they're full, so they won't provide a lot more benefits. Or for example, the infiltration, that will keep going. So that's why it has a lot more effect. And then we also added the costs. You can see that for some of these measures, we have quite a big range in costs. And that's because the lower estimate is just implementing these measures. So how expensive would it be to just plant trees everywhere? Which apparently is not so expensive, around 16 million euros for 10 square kilometers. But if you take into account the land acquisition costs, because most of this land is agricultural land, that's very, very expensive. So then the cost increased to almost 100 million euros. And then we can do a small cost-benefit analysis, which is probably a bit more familiar to all of you. And then we can calculate the benefit-cost ratio. And those are, for some scenarios, quite positive. So we do find values above 1 if we exclude these land acquisition costs. But if we include these costs, then for all the nature-based solutions, they drop below 1. And I don't have to tell you that anything below 1 might not be a very good investment case. Yes, but then this is just taking into account the flood risk reduction benefits. And after me, Guillermo will tell you a little bit more about the co-benefits of these nature-based solutions, which are very important, as we can see here, because if we exclude those, these nature-based solutions might not be a very attractive financial investment. So in conclusion, what did we do? Well, we developed a spatial detailed flood risk model that can simulate the flood risk reduction effects on the whole catchment scale. We do see that nature-based solutions can reduce flood risk, but that we also need these additional co-benefits. And this model, we just developed it now for the Gull catchment, but there's also potential to apply the model to other regions. So if you're interested in that, you can always talk to me later or send me an email. And this work is currently being published. So hopefully soon you will also be able to read it online. Thank you.
Are there any questions for Veerle for now? We take a few questions if there are any, and at the end of the session, we can have maybe a bit more of a discussion. Any questions? Ariana?
Yeah. Sorry, I missed. So, well, super interesting work. And when you presented the cost range for reforestation, for instance, it went from 16 million to 100. Can you just go back to this range? Because it makes a lot of difference then in the cost-benefit ratio, no?
Yes, the main difference is if we include land acquisition costs or exclude them. So
if you buy the forest?
So it's like buying out farmers. It's like actually buying the land from farmers. And the lower bound is just how expensive it would be to plant the trees on land that you would already own. So let's say a municipality has like a spare field, then they only need to plant these trees, right? That's the only thing they need to do. But if it's on private owned land, they also need to pay the farmer to buy the land. And that's quite expensive if you look at the average like price in the Netherlands of these agricultural fields.
Hello, there we go. Just wondering, when you're doing the expected annual damage, what's the underlying data set that feeds into that? So how are you modeling annual damage, if that makes sense?
Yes, it's a good question. So what we do is we model several events with different return periods. So we include everything from an event that can occur once in every 25 years to once in every 1,000 years. And then you have all these events, and then you can calculate like the integral over those. And then you have on average what you can expect every year. Does that answer your question?
Yes, but just how are you getting the actual value? So what is that taken from property values downstream, or is that taken from reinsurance, insurance data? What is that value?
Yes, so that comes from the damage model which we developed, and that's actually based on these curves that translate the water depth to a damage ratio. So for example, something between 0, there's no damage, and to 1, everything is destroyed. And then for every building, we estimate its value based on the square meters of that building. And then we know the water depth. And then we can say, well, around 50% of the total damage in this building has occurred.
Sorry, I'm new to mics. You mentioned the co-benefits. Did you look in the study at all at how that would change the cost-benefit ratio? So can you get it over 1 easily by including water quality benefits or anything like that?
I would say hold that thought for like another 15 minutes.
Okay.
Because that's what Guillermo will present. Yes. Oh, there is more questions, but maybe we're running out of time.
One more question, Svenja.
Okay, well, one quick question. So how do you use this in a very specific context? Because I mean, that's always the challenge. So when I sort of work with our modelers, they say, yeah, we can do this for a very specific place-based location. And it comes down to having very specific definition of, what the reforestation actually needs to look like, what the storage pond needs to look like, and all of that. How have you done that, and how sort of transferable is what you've modeled to other contexts?
Yes, it's a very good question. I think the results itself are not super transferable because they're context specific, but I think the method is very transferable to other catchments. So for example, you can give a map of the area where you say, well, these areas we're going to reforestate, and then the model can then tell you what like the new damages would be. But you do need for every catchment, every location, you do need to really draw on the map where you want to implement, for example, new forest. So you need to turn these ideas into very specific locations, which can be very tricky, honestly. I'm not sure I would dare to show these maps in the region and that farmers would be there and be like, oh, that's my field that you're changing. So it is a bit tricky, but you do need to have the specific locations, otherwise you can't really model the effects.
Quick question. The difference you told us was land ownership or non-land ownership. Did you look at something in between, i.e. the land ownership doesn't change, you have a blended finance because the city might, it's a lot of damage, water damage to the cities, things like that, because then the 16.8 becomes the incentive to be paid, not the 100.
Yes, that's a very good point. I did not myself look into that because it's not my specialty, like financing schemes. But in my project, I'm partly part of the NATURANCE, but also on the Dutch project. And we do have people, for example, working on law. And it's one of the cases we're giving them to really look into, well, what can be like the instruments we use. Can we force farmers to buy them out? Or can we do something maybe with subsidies or maybe more like collaborative? But I think that's something that should come more from like practice. I find it very hard as a researcher to say that. So I would say it's a range and there's a lot in between. But I did not model like a specific scenario of these. But I'm very convinced that there's something in the middle.
Thanks a lot, Veerle. We're now going to Guillermo, who will use also the data from Veerle's model and combine it with data on co-benefits.
Indeed. Well, soon we will answer the question to see if the co-benefits do make them attractive or not, but more on that in a minute. I am also a PhD candidate at the Institute of Environmental Studies, also where Veerle and Max and Vylon and Wouter, which is, we're working on the same project. And we're using the case study of the Limburg floods of 2021, which I won't spend much time explaining because Veerle just went into more detail about it. So as I was saying, we're now going to focus on the co-benefits. I won't spend too much time talking about nature-based solutions, but the important thing is that if we do not take into account the co-benefits, we are potentially underestimating the value. And this ultimately will make the mainstreaming of investment in nature-based solutions more difficult. So we're trying to address this. We started by doing a stock taking process. So we'd say, okay, what are the valuation studies that are out there in a global scale? And together with Andrea from KIT and CMCC, we looked, okay, let's do like a systematic review, seeing what are different models, approaches are people using to estimate the co-benefits of nature-based solutions. And of course, there's like a very large lack of standardization. People use economic valuation techniques such as stated preferences that is we're going to present in a second. There are more other modeling approaches. And as you can see, a lot of the evidence is concentrated either in Europe or North America. We find that as well when we conduct a meta-analysis with using this data, which is one of the shortcomings that we have now in the evidence of the co-benefits of nature-based solutions. Overall, we find that there's enough evidence to confirm the effectiveness of nature-based solutions in reducing risk. And as I was mentioning, there are multiple approaches and multiple ways of getting into getting the co-benefits of nature-based solution that can sometimes also difficult comparison or applying it in different contexts. And one thing that we found interesting is that the role of stakeholder engagement is quite important, and we found it ourselves when we were conducting estimating the co-benefits for our case study. We talked to the people in the region of Limburg and to policymakers, and we kind of changed the design of our state preference because we realized what are the things that were important for them. And in doing so, you can also identify what are the most important co-benefits as well for the area. So we gather all of this evidence from all around the world, different techniques of estimating the co-benefits of nature-based solutions. So we thought, okay, let's try to create a tool that can be applied by policymakers out of this. So we developed a meta-analysis. So we took all the stated preferences studies, which are survey-based studies that they elicit the preferences and estimate the willingness to pay, can be yearly or per month, for a particular ecosystem service or environmental good. And the advantage of this meta-analysis is that it allows you to derive a value transfer function. With a value transfer function, it can overcome the difficulties that it comes sometimes with gathering primary evidence to estimate the co-benefits of nature-based solution, which can sometimes be very expensive or unfeasible in some cases. So we have multiple study sites, which we are our case studies that we implemented, and then we build into our database. And from this, we estimate meta-regression. And the idea is that when a policymaker wants to estimate the co-benefits of a potential nature-based solution that is being planned in a particular site, they can take the different characteristics like, okay, where is this going to be implemented, the GDP per capita and the socioeconomics of the region, and get an approximate estimation of the value per hectare. This being said, it's always preferable to have primary evidence, of course, but this can give you a very good approximation of the value per hectare of certain co-benefits of the nature-based solution that has not been implemented yet. So this makes this tool a very effective way of getting ahead and trying to plan ahead for the investment of this particular nature-based solution. So as I said, we did this through meta-analysis, and here are the results of the regression. Some findings are quite common, such as like that the value per hectare of a nature-based solution of the co-benefits, they decrease by size. So the larger the nature-based solution, the lower the value per hectare. Of course, it's also correlated with like higher income, more like nature-based solution in more wealthy areas, they usually yield a higher willingness to pay on average. And we find some other interesting results, such as like the people on average value aesthetic appreciation or local climate regulation, such as like the control of temperatures in a city. Quite highly, they're associated with a higher willingness to pay. But for example, if you look at tourism, we get like a negative impact. Of course, if you the confidence interval is a bit, if you like, it also gets positive. But these mixed results about tourism can also maybe be explained by certain areas where tourism is by the locals is not necessarily seen as a good, but it can also disturb the local life and create other disbenefits as well. So using this, I'm just going to show a small, like a very short application of this function, and then we're going to jump back to the case study of the 2021 European floods, and we look into whether if the co-benefits make these nature-based solutions a good investment or not. So we took the case study of Essen. There's like an old factory that they're turning into a green area, and this is a way to illustrate what are the different characteristics of the policy that you will need to feed into this model in order to get a value per hectare per year. So in this case, you look at the area of the nature-based solution, population density, because usually nature-based solutions in more densely populated areas are also more highly valued. Continent and risk being addressed. And then with that, you get this estimation, which, as I said, should not substitute primary evaluation, but is a good tool to use when this is not possible. So the idea is that you can combine these with, if you have like a risk reduction estimate or like expected annual damage reduction from hydrological or physical modeling, you can use this for decision-making tools such as multi-criteria decision analysis or cost-benefit analysis. So back to our case study. I skipped the explanation because you've heard about it already today, and it's quite late, so I won't explain it again. So we did a discrete choice experiment. So we distributed to 2,000 households in the Netherlands, and discrete choice experiment works in the following way. The respondents always see 3 different choice cards, and they need to choose their preferred option. This usually involves an opt-out option and then 2 different nature-based solution policies with different characteristics that we call attributes. These attributes are additional warning time, the increase in the cost that this nature-based solution would be associated with. To make it realistic, we use an increase in the waterborne tax. Whether the nature-based solution would be available for recreation or not, and other benefits. And then each respondent needs to, I think we had 8 choice cards per respondent. And then at the end, you model how much the willingness to pay is essentially how much can you increase the price, decrease the price. Let me get in. If you increase an attribute by 1 level, how much can you increase the price? If you increase the price, would keep the utility constant. So it's basically a marginal rate of substitution between the coefficient of each of the different attributes and the cost coefficient. If we look at these results, of course, we expect this to be positive, right? Like if we are offering the respondents benefits, the coefficient, the sign we expect it to be positive. We expect like they will increase utility with additional warning time, increase biodiversity, recreation options. But we find something quite interesting, which is that the land use variable has a negative coefficient, which means that respondents perceive giving up agricultural land for nature-based solution as something that decreases their utility, and they will have to be, in this case, compensated for this change of the economic land use of the fields. Which, of course, you can also make an argument for why this could be the case, but it's nonetheless interesting that the respondents, at least in this Dutch context, they're not really willing to give up agricultural land for, in this case, reforestation policies. We were also wondering, is this because these are average, right? Are there subgroups in the population that we're not being able to identify that are really driving these results? So we did something called latent class analysis. So we try to identify, are there different subgroups in the population that are defined by the characteristics that we know about them, that each of these different groups, they value nature-based solutions and each of the co-benefits in a different way. So we identified 5 different classes, and it was quite interesting that there's a 33% of our sample that is really driving these results. So they exhibit a really big disutility from changing land use from agricultural land to nature-based solutions. So finally, we get to the answer to the question. So we combine the risk reduction results from Veerle's model, and then we combine it with the co-benefits that we estimate through the cost-benefit through the discrete choice experiment. On the one hand, we have the land acquisition cost, which, as you already probably assume, looking at Veerle's data as well, and she explained, is one of the main drivers of the cost, because this nature-based solution that we're looking at here is 1,000 hectares that will be used for reforestation, which means that the high cost that you have to pay per hectare makes it very difficult for the nature-based solution to be profitable in this scenario, whereas the management cost and the setup cost are not as large. So this makes you think as well that if you can try to maximize risk reduction while not using that much land, then it will be easier to make an economic case for this, like why is it a good investment, or maybe even finding some innovative solutions where you just don't buy out the farmers, but you find some ways of for them to keep conducting some of their activities while also trying to reduce risk. Still, risk reduction is the main economic benefit from these reforestation policies, but you can see that you need the different the different co-benefits such as recreation, biodiversity, warning time, and the aesthetic value, which now we call reforestation, to make it a profitable investment. This is a 30-year time horizon, and we're using a 2% social discount rate, which is low, but it's the latest guidance by the Dutch government recommends a 2% social discount rate for cost-benefit analysis relating to nature and biodiversity. But of course, we wanted to test whether would this still be a profitable investment and we get a positive net present value if we change the social discount rate. So we have in this graph the retention ponds and the reforestation under 3 different social discount rates, 1%, 2%, and 5%. And as you can see, retention ponds, since you don't really need that much land to purchase, you get almost in the first 5 years, you get a positive return. Whereas for reforestation, it takes much longer. But with lower social discount rates, you actually get a higher return on investment than with the retention ponds. This is not the case as you increase the social discount rate. So just for clarification, social discount rate basically estimates how much you value the present over the future benefits. So this is quite interesting. And as we can see, like basically the amount of land that you need to conduct these nature-based solutions is really the driver here. But you do need the co-benefits to make a case of why you should invest in nature-based solutions in this particular scenario. And as I mentioned before, different approaches that can make agriculture and these nature-based solutions potentially coexist could address this challenge. Of course, as you saw in Veerle's presentation, there is other nature-based solutions that have been modeled, and the next stage would be to also conduct this analysis using those and combine measures as well. And now I will give the floor back to Max, which will reflect on the insurance implications.
Yeah, so how does this story relate to insurance? That is the next question that I will briefly present on now. Well, one of the questions is, well, who benefits from these nature-based solutions? And well, if we look at insurance, so the effect, of course, the nature-based solution reduces risk, and therefore it might also impact the premium if these are taken into account by insurers. So here we did an analysis. We applied a insurance model to assess insurance premiums under different insurance structures. So these are kind of hypothetical or conceptual insurance structures. One is risk-based, where premiums reflect the risk on quite a detailed scale. Then there's a flat rate, so this is more of a solidarity type of insurance structure, and a capped risk-based, which is more or less, well, it's quite similar. So the main distinction here is that there's kind of a solidarity insurance structure and a more risk-based structure. And we assess average premiums here under baseline, so under the current conditions in the floodplain, and when installing retention ponds and reforestation. And what we can see is that under all of these scenarios, actually insurance premiums reduce on average, of course, because the risk reduces. What is interesting is that depending on the insurance structure, it impacts who benefits. So if it is risk-based, then mainly the high-risk households, they are going to benefit. Whereas if there's more of a solidarity type of structure, if premiums are flat, then it is mainly, or then the benefits are spread evenly across the people that potentially pay for the nature-based solution. So then we can also apply this into an investment case where under very specific conditions, an insurer might contribute to some extent to investing in the nature-based solution. So here, and particularly if, so under this situation, the insurer, if they keep the premium constant, they're able to reap a benefit in terms of the reduction in potential payouts, right? So here we look at the expected annual damage. So what if an insurer then pays for a certain amount of the nature-based solution? Then we can see here the yearly dividend under retention bonds in this specific catchment is almost 1 million. And that means an annual return on investment of 20%. So that means it makes its investment back in 5 years, more or less. For reforestation, the dividend is a bit higher. The return on investment is slightly lower because the investment is much higher. So, of course, this only works under very specific conditions when, for example, as we actually discussed yesterday, when there is no competition or when an insurer who invests, for example, in the nature-based solution is ensured that the policyholder does not switch to a competitor. So here the longer insurance contracts would be very important. Okay, so well, if this doesn't work, then if this is not organized, if the insurance system is not organized in such a way, then well, the reduction of risk is still very important, and insurance might still play a very important role here because there's a large insurance coverage gap, and using our insurance model that we developed, we were able to assess this insurance coverage gap. So it's the demand for insurance when this is voluntary. And we can see, insurance penetration rate as we modeled it under the different scenarios. It does not really change much. So here we take into account also, for example, unaffordability, how much of the premiums, to what extent do people purchase insurance coverage, considering also unaffordability. The long story short, the advantage here of the nature-based solution is not per se that it increases insurance penetration or something like that, but it of course reduces risk and therefore reduces the insurance coverage gap, which is a real benefit for governments, for example, who need to pay out uninsured risks in the case of an event. So in that sense, insurance still plays an important role here. Yes, so that I think that's our presentation. Are there any questions on this part? We'll take maybe 1 or 2 questions because this was quite a long session. Yeah. Okay, then let's go to the next presentation, which is Neil, and he's going to do a bit of a yoga exercise, I've heard at the beginning.
I'm not sure about yoga. I'm not that bendy, but could everyone stand up, please? Too many hands. Okay, now you can sit down. It's a long day. It's the second day of the conference. I woke up at 2:30 this morning and I thought I'd read myself to sleep, and at 6:45 I thought I'd go to breakfast. So I might falter occasionally, so feel free to throw things at me. Right, the advance is right. Right. Okay, so thank you for having me. This is going to be a little bit of a journey from these engineering studies, really, really interesting. I've enjoyed them. My career through several years, 25 years at the Environment Agency, and hard engineering, flood management, and then to the transition to working at an insurance broker. So I'll canter through some of it because it's already been ably explained by my colleagues here. Thank you. So just a little bit about the Willis Research Network. Willis itself is an insurance broker. We've got nearly 50,000 employees in 140 countries in the world. And our client base tends to be corporates, people like Amazon or BHP or Citibank or something like that. Within Willis, there's something called the Willis Research Network. What we like to do is to try and understand risks to help our clients get better insurance, do better risk management. Within the team, there are subject matter experts. Some of them will be working on things like geopolitics, and some of them will be working on things like natural hazards. And as natural hazards go, I am the flood and water guy, and I deal with problems of too much water, too little water, and water that's not good enough. So floods, droughts, and pollution. And we don't thrive on our own wit, into just our own wit, but we rely on research partners from decent universities all around the world and think tanks as well. Okay, so that's how the Willis Research Network works. All right, so we'll race through hard engineering flood management. It's normally putting things back the way they were before we cut all the trees down and broke the earth and everything else, and replacing it with engineered solutions made out of things like concrete and metal. You either hasten the flow of water to reduce the risk in a particular location, store it, or build walls to exclude it from places. And most of these things make flooding worse somewhere else. But generally, you talk to those people first and try and pay them back if you're doing something bad. And just to look here, you got, oh, where's my laser? Is it at the top? Well, okay. Everybody will be used to the street gully and a highly engineered channel there, trash screens, massive water storage thing underneath Tokyo, and then concrete sea defenses and walls, and a flood storage reservoir that I used to drive. So nature-based solutions. I can't see Verena here, but I stole this off her website. Thank you very much. They're just ways of putting things back the way they were, perhaps, but maybe making them thrive within an engineered landscape at times, particularly in urban areas. And they often have lots and lots of co-benefits that we've talked about. Are those co-benefits always in somebody else's capital program when you go to them to build a flood defense and you say, I'm going to give you some mental health benefits, I'm going to give you some lower city temperatures? Are they always within the capital programs of those other beneficiary organizations who are largely state-based? Anyway, that's just a question I'm going to leave you with. And I'm also going to give a little thank you here to Doug, because there's a lot of overlap between our material as well. Great minds think alike. I'm going to go for that one, not the one about differing. So along the top, you've got your engineered solution, and along the bottom, instead of a coastal defense, you've got a mangrove swamp. Instead of a flood storage reservoir, you've got a wet woodland and a nasty river sitting above the floodplain. It gets replaced by connecting the river to the floodplain and having natural storage. And one nice feature of all of these things is when they fail gracefully, the nature-based solutions. When a big flood storage reservoir fails, you could have a 10-meter wall of water whizzing down a catchment to the community that's been developed in the shadow of its benefit. So nature solutions fail gracefully. And a lot of things that we're building now are failing. So that's actually quite a nice feature. All right. So I've just been looking at the fluvial and the coastal risk, just having a look at the urban risk, which tends to be driven by pluvial, but obviously there's coastal cities, so there's overlaps between different sorts of risk at times where you have co-occurring risks. And in the urban situation, you find many, many different overlaps between blue, green, grey, and hybrids of all of them. And this is because cities are very, very densely developed, and you're making spaces multifunctional. So your park becomes a flood storage area or a conveyance area or a bit of both. So you see lots of overlap here. Okay. So I've been asked to talk a little bit about measuring the benefits, and it's late on the long day of the conference, so we must have some fun. So let's talk about some bad news first. And someone's having a bad day here. And there is a bit of a pick and mix of problems with fluvial-based, nature-based solutions. So notwithstanding what you've said, because there are clear demonstrations that they do work, but there's some difficulties with delivering them. And I've been speaking to some of the people who deliver nature-based solutions in England, because that's my area of speciality before I joined Willis. There's one guy, he's doing nature-based solutions in the southwest of England. He's passionate about them. And he looked at 1,000 square kilometre river, and he said to me, if I want to get a decent standard of defence for the city at the bottom of this catchment, it's 1,000 square kilometres, to let's say a 75-year standard of defence, which would help with insurance premiums, I have to have a 5,000 square kilometre catchment. But it's only 1,000 square kilometres, so he can't attain this. He can attain benefits, but he can't necessarily attain what society or insurers want him to. The second thing is, if I look at farmers within the catchment, and we've just been running some things at Willis on the transition from, let's say, intensive agriculture to perhaps regenerative agriculture, half the farmers want to keep smashing the ground and spraying things and pressing into modern techniques rather than regenerative agriculture. And that's the way it's going to be, because farmers change doing what they do quite slowly. They're quite conservative. But really things are changing perhaps faster than we want them to, and faster than societies are elastic, if that makes sense. Okay, so there are some difficulties. And then one other thing is that within nature-based solutions, there's a community of people who want to do them, and the first group of people who want to do them was more the ecologists and the engineers, and they were often doing them because they wanted newts or frogs or something, and they said that a co-benefit would be flood risk reduction, and so they definitely delivered what they were intending to do, but those co-benefits were poorly quantified in the design of the scheme, and they didn't put in any experimental design to assess those co-benefits. Okay? Right, so here's some good news. No picture for the good news because you should be happy with it anyway. But here's the good news. The gold standard for science is emerging. I'm referring to a really good study in the Journal of Flood Risk Management. It's a review paper. They've looked at several hundred schemes. Some of them are longitudinal, and this is one thing that's missing, where the scheme has been in place for long enough to catch a few big events, a 10, a 25, maybe even a 100-year flood event if you're lucky. But what they found is, in the design of the schemes, that the real gold standard is to measure the river level, measure the flow, do that continuously, and couple that with the kind of hydrodynamic modeling the two guys who preceded me have mentioned. So that design gives us that enhanced risk understanding and builds the argument in favor of doing nature-based solutions. Good news. We talk about measuring the benefits in a cityscape, or we talk about measuring the benefits in coastal. I'll start with coastal. This is kelp, and it's great stuff. Heriot Watt have done a study where they've looked at 30 to 70% reductions in 100-year wave height off the west coast of Scotland. And that's a place where you're looking at 8 to 10 meter high waves. So this is a really significant benefit. And oysters, so oyster reefs, they're pretty much the same as a breakwater or a seawall, but they're just edible, and they fix carbon as well, and they clean the water. So what's not to like? And then in an urban situation, this is a nod to the Australian Green Infrastructure Network. And if you think how hot and intense and tropical the weather is in Australia, it's the lab bench for what we need to do here. So I implore you to have a look at that, and there's a slide of references at the end. So within these areas, these solutions have been deployed for longer and more systematically than in the fluvial environment. Okay, I'm sorry, we're back to the bad news again. I don't know if as a parametric event, if two cars went past, this truck would be a big loss event, I think. Are they going to make it? So I then looked through some CAP models that were made by major European vendors. I looked at European flood and pluvial, read through the 400-page documents that go with these, and one for UK flood and pluvial. And I noticed that tide and surge are quite well represented in terms of incorporating flood defences into the model. Fluvial levees, they're kind of okay. One of these models split the major European rivers into 8,500 kilometres of major, and then all the other rivers were called minor. And on the major rivers, they brought the flood defences in, particularly in countries where the data was dense. But on the minor rivers, they assumed a standard of protection of, I think it was 1 in 30 to 1 in 50 years. This is just wrong. All the rivers I used to manage, they would be out of bank on a 1 in 2 or a 1 in 5, not necessarily causing property flooding, but certainly causing problems. And you couldn't assume that standard of protection in those circumstances. There's two other big ways of defending things that we've talked about with fluvial, and that's the channel improvements and the flood storage reservoirs. And they're rarely capturing the conveyance. They do mention when they do, but not everywhere. And in terms of storage reservoirs, many of them are manually operated or operated according to quite complex rules, which are too much to put within a CAP model. Pluvial flooding in an urban area, it's really, really complex. You just have to make some assumptions about how much of the rain sinks into the ground. And it's very hard to acknowledge the presence of urban drainage improvements because, for example, in York, they're still using Roman sewers. And so the infrastructure is just so varied, it's very hard to get a true picture of the risk. Nature-based solutions just don't feature. And there's some reasons why. That amount of benefit is variable depending upon where you are. They're quite complex, and the data is incomplete. And so we just have a quick look before I hand over to the next presenter. At what we might need to do to make the situation a bit better. So we have to be curious, like this little guy or girl, not sure which, and we have to think about some different features. So if I talk about design, perhaps, and I'm going to need my notes here. I knew this was where I'd flag, because there's lots of notes. Don't take the picture of me when I've got the notes. Right, so we've heard that when you plant some trees to reduce the risk of flooding, it takes a long time for those benefits to be reaped. Can you transfer the benefits from one place? What works in place X, will it work in place Y? Can you be confident about that? And how does it fit in with your grey infrastructure? The second thing is the efficiency with which it works. So there's quite high performance variability, not just because of the time it takes for NBS to get working, but within a year or from year to year, you might find that you have a drought. Well, how does that make your flood ponds or your wet woodland work? How does that work with your soil infiltration rate, where you've just tried to improve that through increasing the organic matter and cutting tillage? It's quite a difficult thing to quantify. And then with climate change, let's say you go, well, I'll plant this kind of tree to interrupt the flow of water along the floodplain in 50 years' time, which an insurance model isn't going to reach out that far, but an investor will be thinking about that, and that investor is likely to be a state entity. Will that kind of tree, will the agroecology be the same? So if I just tell you that Tattinger, who makes champagne, they do that somewhere someone who's French, tell me if I'm wrong, they do that somewhere around Rennes. They bought land in Kent, which is just south of London. They bought land in Essex, which is north of London, in Hull, which is pretty much in Yorkshire, and then they bought land in Aberdeenshire, which is at the top of Scotland. And they're doing that because the agroecology is moving. So will those measures work? Will people invest in it? Nearly finished. Okay, so we've got that long variability. Then there are some questions over maintenance, and I'd love to look into Guillermo's maintenance stats for nature-based solutions, because I had a chat with a couple of flood risk managers, one in Cumbria and one in Devon and Cornwall, and they don't know how much it costs to maintain their nature-based solutions, and this will surprise you, they don't know where they are or whether they're there. So with all of the flood walls and storage reservoirs and these engineered solutions, have an asset database because they own the land or have rights over the land where the interventions are. So they know exactly where they are, and they go out and look at them all the time. And people are trained to look at them on a visual condition basis, and maybe send an engineer if there's a problem. But with nature-based solutions, the training to understand what you're looking at and whether it's going to function efficiently isn't there at the moment. And because many of the interventions might be in the uplands, remote from the river, and they're dependent perhaps on policy instruments like the Common Agricultural Policy, whatever comes next, you can't be sure that they'll be there or that a farmer will continue to do them and might not change. So these questions, these doubts and risks and uncertainties, we need to overcome them. We need to get ourselves in a position where we really are embracing nature-based solutions, because they have the ability to, whilst the engineered defences that we have give us a standard of protection now, I'm told that the nature-based solutions will give us the capacity to mop up the increase in flood risk arising from climate change. So we need to overcome the problems of how they work, where they are, how to inspect them, and how to make sure that they're sustained through time. Okay, thank you very much.
Maybe a quick question to Neil before we go to the last presentation. If there are any? Okay, then save it for the next one. Vylon.
Yes, thank you. Let's see. So the very last presentation of the day. So let's make it also like an interactive session, please. That I'm not the only one talking, but that also like you give some ideas as well. My name is Vylon. I have actually two hats basically. So I wear two hats. One, I'm a policy advisor on climate adaptation for the Dutch Association of Insurers. And two, I'm an external PhD candidate at the VU Amsterdam, who is also involved in NATURANCE. And I'm the project leader also on flood insurance in the Netherlands. So we already had some discussions about a protection gap, for instance. I'm leading those discussions in the Netherlands currently with our government. These are our members. So you might recognize some international players, but these are all insurers that operate in the Netherlands, and the Dutch Association of Insurers, like 95% of them are a member of the Dutch Association. So that means that we have a mandate to speak for the insurance sector in the Netherlands. These are all insurers except for healthcare insurers. They have their own association in the Netherlands. What we do see is that there is like more and more attention on insurability. In the Netherlands, the main uninsurable hazard is actually flooding of so-called primary dikes. So I will show some pictures of the Netherlands later on. But we have next to the sea and also the big rivers in the Netherlands. If they break, then it's uninsurable, but the rest is insurable and actually by default insurable. And we also see that it's actually so the protection gap is closing in the Netherlands, or like at least like getting smaller. In 2021, for instance, flooding of so-called non-primary dikes, so think about like small rivers and canals, are actually now insurable and also insurable by default. So And that's also showing where data actually leads to decisions of insurers to actually incorporate it because they can calculate it. What I do recently see is that banks are actually more and more talking to us about insurability, mainly because of European regulations where they don't only have to see when there is a mortgage or when they have to talk about a mortgage with their clients. If there is an insurance there, because often there is an insurance, there needs to be an insurance, so property insurance, but also if that's an adequate insurance, so how adequate that insurance is. And I will talk like later on about an example where you see that that's a bit debatable and where currently now mortgages are more under pressure as well. And yeah, the others you can see like so we in the Netherlands we have so-called water boards. I will talk about them later on as well. These are governmental bodies that specifically focus on water access and also water quality. So what we do in the Netherlands, so we have, because it's 95% of the market that is member of the Dutch Association, we also have the damage data of 95% of the Dutch insurers operating in the Netherlands. So there are a few figures that I'll use with text in Dutch. I will explain them. So for the non-Dutch speakers, which are many of you, I will explain these, and if you have any questions of them, please ask. So on the left-hand side, yeah, for you left, we see on the left-hand side the our own climate damage monitor, which shows the annual weather-related damage in the Netherlands. It's from 2007 that we have that data. What we see mainly is, yeah, the insurers among you won't be surprised, but we see a big hailstorm that's in the middle. So the bright blue peak in the middle, basically. Then two big winter storms in 2018 and 2021. And you see like a minor one just before the 2020 or 2022, I have to say. The one before that, a slightly minor one, is the one in 2021, and that's the Limburg event that also Guillermo and Veerle mentioned. So this picture also, if you looked closely and you paid attention, you also saw the picture on the left-hand side in Veerle's presentation. But this is Limburg. And then on the right-hand side, we see an example of last year that happened in Enschede in the east of the Netherlands, where there was not even actually that much of a rainpour, of a downpour, but still some houses flooded, and those people, it's about 40 houses, can't enter their home for the upcoming 8 years right now because of restoration. So these are examples that we want to prevent. And it's actually mainly because they had a ground level of water, and there was built when they started, like let's say 100 years ago, and there was a beer factory next to it. And that beer factory actually, because they needed a lot of water, the water level was very low. But then that beer factory moved out. So, and then of course the water levels rose, and then there was some precipitation, and then they had immediately damage after all. And you see also a severe lack of nature-based solutions, I think, over here. But you see where previous planning is actually can differ and can be a bottleneck. So the Dutch government actually showed basically like signaled now where you can build and where you can't build. So in the Netherlands, we have this so-called housing crisis where you have to build like 1 million houses in the upcoming years. But they already show where you can and where you can't build in the Netherlands. And I think this is a very interesting example of preventing some things that happened where you get some kind of locked-in effect. Okay, I will build in a flood-prone area, and then I will have a problem. So red is of course you can't build there. You're not allowed to build there even. So think about unembanked areas, for instance, that are not protected by a dike, but also those purple areas and orange areas are areas with like severe challenges actually to build there. For those among you who know the Netherlands a bit, like most people live in the West, so this will be quite a challenge. But we have to move to the East, basically. The other one is how to build. So the Dutch Ministry of Infrastructure and Water created the so-called maatlot, We won't go through all the categories, but one of the category actually on the left-hand side is biodiversity and nature inclusivity. So, so they already take this into account, and right now they want to put the basically water nuisance rules in rules and regulations. We really support that because currently it's only guidelines. So what we often see when there is project development, that they develop something that's very climate adaptive and biodiversity proof, but then it gets expensive and more expensive, and then they only look at the mandatory things, and then the climate adaptation part then just get cancelled in the plans. And if we put this into not into guidelines but more into rules and regulations, then it's mandatory. As I said before, I basically wear two hats here. So I'm also doing research at the Vrije Universiteit. So within that research, we work together with Amsterdam Weerproof, which translates to Amsterdam Weatherproof, basically, and it's a organization that within the municipality of Amsterdam stimulates climate adaptive building and also climate adaptive planning. So they were like greening or improving a neighborhood that flooded often, called Rivierenbuurt. And they started with the Scheldebuurt, so you have the Scheldebuurt and the Rijnbuurt, so on the left-hand side. In 2018, they started with the Scheldebuurt, and the Rijnbuurt, they only just started. And for us, this was a very interesting example that we could do research on, because we have like two very similar neighborhoods that are flood prone. But there were a lot of nature-based solutions installed. So as I said before, so more like water storage areas, green parts of the street, green roofs, those kind of things. So we researched that. We did so using that damage data that I said before of 95% of the Dutch insurers. And we looked specifically at heavy rain damages using a difference in difference method, where we just like combined or like compared, I have to say, both neighborhoods. What we did see there is that after those municipal nature-based adaptation measures were implemented, we saw significantly less heavy rain damage in that neighborhood. So in the neighborhood where measures were taken compared to the neighborhood where no measures had been taken yet. So it's an interesting example of how that can work, and how that also can attribute to a reduction of damage. So this is mainly, it's not only on building level, but it's also on community level. So these are what I said, streets and parts of the neighborhood. If you look at what you can do on a building level, the Economic Institute of Builders in the Netherlands, the EIB, actually did some calculations on what it would cost in newly built housing to adopt several of these measures, mainly focused on water nuisance. What we did see there, and these columns here, so the one on the left-hand side, on the middle, and on the right-hand side, actually correspond to these colors. So in a very in like such a green area, basically, it would cost only 400 euros more. In such a in the middle, so let's say in a yellow or orange area, it would cost like 7,700 euros more. And like in a more like very deep orange or purple area, it would cost like 11,800 euros more, which is not a lot if you compare that to house prices. So you would think, if you would see this thing, like, okay, this could be this could be incorporated, and especially mandatory. I have to say though, this is only on water nuisance, so this is not incorporated like heat or others. Usually heat are the most expensive measures. And what I said before, so we have one area where mortgage lenders are now asking questions, and those are the unbanked areas in the Netherlands. That's roughly 4% of the areas in the Netherlands, but some very highly populated areas like parts of Rotterdam, for instance. And there is no insurance coverage for flood over there. And the municipality of Rotterdam is building 20,000 houses extra right now there. So there's a lot of development there. And because of that, mortgage lenders might actually say, like, okay, we won't give you a mortgage, or you have to pay a lot more to get a mortgage. The municipality, so it was a bit stupid, but 4 years ago, I went to the municipality and said that, and they didn't know that there was no flood coverage there in unbanked areas, which was to me quite shocking. But where you see that worlds actually are very separate, and the ones that then are in trouble later on are the people that live there. And often those people that live there also don't know whether they are unbanked or not, because sometimes actually the dike is actually like not really visible. So this is a clear problem that we have here, or at least in the Netherlands, where we see like, okay, quite some people might be under pressure pretty soon. So because banks are already asking about that, which also, yeah, gives us a bit of a question, like, because those areas like so they are not protected, so they flood often. And Max also talked about like insurance as a solidarity-based product. So often, yeah, there is a risk, and you try to spread that over a lot of different people or assets. But also living in an unbanked area, yeah, so you kind of like not ask, but it's like damage prone. So yeah, is it still also solidarity based to actually live there or not, or choose to live there? So it's a bit of a different ways of thinking about solidarity in this case as well. Like are those people unlucky that they get damage? Or if you choose willingly to live there, is it fair that others pay for your damage time and again? So this is a question we struggle with as well. I'm curious to hear your thoughts later on as well on this, but it's a bit double here. So we also are exploring our roles from the association of, okay, what can roles be of insurers? So obviously insurability, so providing insurance, providing coverage, providing a safety net is a very important one. Information provision and early warning are two that are, of course, important. Like we said, insurers have a lot of information on risks, and can provide these as well. In the Netherlands, about like 95% of the people is insured actually, because it's mandatory for a mortgage. So insurers have a lot of contact with clients as well. Investment in climate adaptation, we already said, and build back better. So it's like, if insurers can, if there is a damage, if they can restore it in a better way, retrofit it in a better way. And also there, for Build Back Better, it can be interesting if the government imposes rules and regulations to say, like, okay, for instance, in the Building Act, you have to build climate adaptive already. Then if they have to, then insurers have to also retrofit in that way, and then you can incorporate Build Back Better more easily. And as I said, also like mortgages is one that we see more and more now that mortgage lenders are asking for climate adaptation as well. Some examples in the Netherlands of where we see climate adaptation and insurers' efforts. I see some examples already, but it's quite slow and it's quite iterative. So there is one insurer that incentivizes taking tiles out of the garden. I know here in Belgium it's mandatory even, or at least in Flanders. But you see that there are some insurers that incentivize this. There is an insurer that sells green roofs and gives premium discount if you have green roofs. So that's an interesting example as well. And this year I saw the first climate adaptation mortgage in the Netherlands, where there was one insurer actually that's also a mortgage lender that said, like, okay, within your mortgage you can lend a bit more if you take climate adaptive measures as well, like you have sustainability linked mortgages as well. This is a question actually. So I prepared my slides before our event here. This is a question we of course also touched upon yesterday. So why insurers like don't invest much in public flood defense infrastructure? This is also a question we will tackle with Water Europe. So I'm part of a finance and water expert group where we're currently designing a playbook that tries to bridge those languages between like the water language or the water world and water sector and more of the financial sector investment, but also insurance. And I think this is an interesting one as well. I see that quite some of the text is actually merged, so I do know where the space button is in my, but I think you can still read it. So in 2024, one effort of Insurance Europe as well, where I'm part of as well, who contributed to the climate resilience dialogue, where there were some things I touched upon as well, given into advice. So Build Back Better, which we see a bit happening in the Netherlands currently, but would actually help us if it would be mandatory, because then the whole market can move instead of just one or two insurers that would do that inside of a product which we don't see. Climate adaptation advice for customers as well. Quick and adequate claims after a disaster. So think about the parametric insurance as well, which we discussed earlier today, where you can immediately pay out instead of an indemnity-based insurance where someone has to pass by and has to check what kind of damages you actually have. So it can also be interesting to have a look at that. And currently they're designing a water label in the Netherlands on houses. So see what kind of flood risk you have and incorporate that into houses as well and housing prices. So this is an effort that will be there at the end of the year. And at Insurance Europe, we're also working on a position paper on this, on climate adaptation, to also extend this, because we see a lot of similarities in a lot of different countries. Like this year, I went to the UK and also talked to Australian colleague, who also say like, please, okay, climate adaptation in building codes would really help as well. I see that my last slide is not there, but that's no problem. So my last slide was basically just my email and thank you. So if you want to like ask a question later on, feel free to reach out. I'll be there tomorrow as well. So thank you.
Is there a question for Vylon? Any questions?
Still have 4 minutes, so
4 minutes till the end of the day.
4 minutes until dinner as well.
Nice.
So oof. Yeah.
Is there?
Oh yeah. Well, our members often ask like, okay, please quantify these as well. So this already really helps. This research actually directly contributes to questions posed by insurers, at least in the Netherlands, that would really help to understand this better and also understand the way of how they can incorporate it for instance, in their products. So, so it is really relevant, and it's also often based on questions that we had before. So it's practice driven, this research as well. Yeah. Neil, you have a question?
Well, no, a little bit of an answer. The nature-based solutions aren't in the models. The models are big and generalized. They're not like one catchment. They're the whole of Europe or the whole of the UK. They haven't got all the hard engineered defenses in, let alone the nature-based solutions. That should change, but you need the data. You've got to get the data.
We need data, so.
All right, thanks a lot for your attention and your engagement in this session. So we had interesting presentations on our work in NATURANCE, on developing new methods to be able to do a cost-benefit analysis, and some interesting reflections of research, how it is applied by the insurance sector, and the potential roles that the insurance sector can play in realizing nature-based solutions. Priscilla or Jaro, do you want to close off the day?
Lovely. Thank you very much, Max. And thank you very much, all the speakers of the last session. It was really, really good and very informative, very interesting. I see there are plenty of guests still here. That means that the spirit of the discussion is with us. This is brilliant. Well done, everybody. Thank you very much for staying. Priscilla will explain what will happen tomorrow. We still have one session tomorrow morning, so you are very welcome to continue supporting this. So it has been very nice, what we have seen today, the morning, and also the work cafe tables in the afternoon, is there are many good ideas how to translate this marriage between nature restoration and the financial services like insurance or risk management, financial risk management in general. So they are good solution, and we have seen across the different tables and the discussion groups that there are common challenges, like it works in small scale, but how to upscale that, or how to get the information at the local ground, right? What is really the benefit and who is benefiting and so on. But all those might be managed. But I would like to share one example that I got from the table, and it was really good. So somebody from Denmark brought the example of Denmark is still using the untreated water from the aquifer, paying relatively, cheap water supply, right? Because they have a good quality water in the aquifer. But this is changing, right? Because of the pollution, diffuse pollution, fertilizers and pesticides and so on. So they're a little bit worried about the quality of the water. So if the quality of the water get deteriorated, then they start paying more for the elementary water supply. Now, transmit the same logic also for what we are talking about in terms of insurance. As long as we have a healthy ecosystems providing regulatory services that help to mitigate the disaster risk, then we are paying less, right? As soon as we destroy those ecosystem services or don't pay enough attention to preserve them, then we are going to pay more, right? So it's exactly the same. It makes very tangible what we are talking about. So bringing in the environment in the CAT models, as has been discussed, as has been also demonstrated in this example, is critically important, because otherwise we are driving a car without knowing where we are going to, right? So it's very, very tangible example how to explain similar issues to your colleagues or your somebody who's interested in your work, right? Make examples, right? Explain in the same language that the people is used to explain how this might impact our future. So this is my personal lessons learned also from the table. Otherwise, we have been also discussing very important topics on the nature credits. You might know Europe is exploring a new type of hopefully a financial instrument, right? We have nature restoration law. There is binding requests to restore degraded environment. There are very ambitious deadline milestones for doing that. And there is the idea that the nature credits might accelerate this, right? And it's similar, right? That in UK case that has a similar legislation, we have made a connection how the insurance might help to generate similar, or might be interested to invest in similar credits, or might harness those credits in order to reduce the risk, right? And the UK case that was presented earlier is a very nice example of how to do that. That might be something to learn in other parts of Europe. So for me, it has been really wonderful day, full of knowledge. It's incredibly rich what you all brought to the tables and what in this project has been produced and collected. So well done and thank you to everybody. And over to you.
Just to close the day. So We started the event. The first day, we were discussing policy initiatives from the EU that can enable private investments in nature-based solutions. Today, we discuss solutions. We discuss evidences coming from place-based research and also concrete cases, right? So tomorrow, we have 2 sessions. We will be from 9 to about 1. And the first session is exactly kind of nailing this all together. So will be the policy recommendations coming from evidences, place-based research from different projects, NATURANCE, Soteria, PISA, Invest for Nature. They would present to us their policy briefs and policy recommendations. And then the second session for tomorrow is more like a celebrative moment. First, we will have the cities presenting their initiatives for citizen engagements in nature-based solutions, and also the Naturathon prize, right? Don't know if you want to shortly explain, or we can. Yeah.
We have not only created a space for dialogues between financial world and the nature conservation world, we also brought this topic to the general public. Davide, you are here. Would you like to say a few words about what is going to happen tomorrow? So what we have done is we run also some exercises for citizens and invited the citizens in form of Naturathon. Naturathon is example of datathon or climathon, if you are familiar with those. And we have basically asked the citizens or anyone out there, right, in the society to create small groups and reflect about how to bring nature into the environment and what is the finance. So what was the result of it?
Thanks, Yaro. It's surprising because I was preparing the talk for tomorrow. But yes, the citizen engagement is the 5th pillar of the NATURANCE because we really worked in these years also to bring citizens to the project and vice versa. So bring the idea that spread out from NATURANCE to citizens. We organized 2 open calls and a series of activities during 2 years, more or less. And we engaged about 500 people and 100 groups. I don't want to grab other time because tomorrow we talk a lot about that. So thanks. It will.
Yeah, come to celebrate those citizen initiatives as well. So we are closing for today's. A big thank you for joining us today, and please be here tomorrow at 9, and we can deepen in this policy discussions. And enjoy your evening.